Let's look at transformations of exponential functions. We can write an exponential function as y equals b to the x, some base to the exponent x. If that base is greater than 1, then we're looking at exponential growth. If that base is between 0 and 1, then we're looking at exponential decay. So what about transformations with our exponential function? You can see that our parent function is b to the x, so that could be 2 to the x or 5 to the x or 1/3 to the x, but this is our exponential function. And the transform function is the same as it always is. We have our a, k, d, and c. So these are the things you can do to your function. I'm going to rewrite that function with the b to the x in it. So what would that look like? It would look like y equals a, and then our parent function is b, and then we have the k up here, x minus d is up there as well because that's where the x is, and then plus c. So that would be the transform function for an exponential function. But what does a do? A is the vertical stretch or compression. It's also a flip in the x-axis, so flipping up and down. Our k is our horizontal stretch or compression. And it could be a flip in the y-axis, so left and right. Our d is our shifting left and right. And our c is our shifting up and down. Now the c is kind of cool with the exponential function because it tells you where the asymptote is. So normally for your parent function, the asymptote is at 0, which means that the function never crosses the line 0, y equals 0. And then if we put a plus 1 here, then it would be y equals plus 1 for the new asymptote. So looking at them graphically, we can see that the red one is the parent function, and in this case I chose 2 to the x. So this is 2 to the x, the parent function. When I multiplied it by 0.2, it's 0.2 times 2 to the x, and this one is 5 times 2 to the x. So our initial value is 5 in this case, and in the green case the initial value is 0.2. So what's really happening is when we do this, we're keeping the x the same, it's working in the y direction. So if I look at the point 1, 2, and I stretch it, so I keep my value, because I'm working on y, not x, I keep my x value the same, and I end up here at 10. So I was at 2, and I became 10, because I multiplied by 5. Did you see that? So this was 1, 2, and then it became 110. So I kept the x value the same, and I stretched it by multiplying it by 5. Similarly, keeping the x value the same, I'm keeping the x value the same, but multiplying my y value by 0.2. So I end up down here at 0.4. So I compressed it, I pushed it down. Here I stretched it up, and here I pushed it down. So stretch and compress. Now I also talked about the a is negative. If a is negative, then the whole function flips in the x-axis. Horizontal stretches and compresses. I am going to start by labeling these equations, so these functions. So this is 2 to the x, it's the parent. This is 2 to the 0.5x because the 0.5 is multiplied by the x. And then 2 to the 2x. So this is what the horizontal stretches and compressions look like. If you look at the points now, on the parent, the 0.12 moves to the 0.22. So I'm keeping the y values the same, but I'm stretching it out, and 1 becomes 2. Effectively, what I've done is I've divided the 1 by the 0.5 that you see in front of the x. Okay? And similarly, the other way, I divided the x value by the number in front of the x. So if I divide by 2, I get here. So with horizontal stretches and compressions, you see a multiply by 0.5, and you're going to divide by 0.5. Here you see a multiply by 2, so you're going to divide by 2 to compress it. And if k is negative, I didn't actually draw that on here, but if we were to take this red function and make it 2 to the negative x, what would happen is it would be flipped in the y-axis like this. So that would be 2 to the negative x. Okay, so I think like I did on the other pages, I'll start by writing the equation. So again, this is the parent function 2 to the x. To change it to the green, I actually moved everything up 4, so 2 to the x, and then add 4. And notice that that asymptote is also y equals 4, because I moved the entire asymptote up. Or similarly, moving it all down, I get 2 to the x, take the whole function, and move it down 2. So the new asymptote is y equals negative 2. So the c value gives us our asymptote. And last but not least, the horizontal translation. And again, I'm going to start with labeling these. So 2 to the x. This is 2 to the x minus 3. And this is 2 to the x plus 4. So if I see plus 4, it means I'm moving left 4. If I see plus or minus 3, that means I'm moving right 3. So it's the opposite of what you expect, and that's left and right translation. A few questions. Describe these transformations. So I'm going to say that this 3 means right 3, and this 2 means up 2. This negative is a flip in the x-axis. This half is a vertical compression, and the minus 3 is down 3. This negative 2, the 2 part means flip, or sorry, the negative part means flip in the y-axis, and the 2 is a horizontal compression. Write the equation for the function that results from each transformation applied to the base function y equals 5 to the x. So the base function is y equals 5 to the x, and the first one we want to do is translate down 3. So we want to go down 3. So our new equation would be y equals 5 to the x, take the whole function and move it down 3. Shift right 2 units. So left and right goes with the x value, so I have to go right. If I go right, that's towards the positive, so I'm going to write negative, negative 2. Translate left half a unit, so y equals 5, and it's happening with the x, and I'm going left, so plus half a unit. I'm going to shift up 1 unit and left 2.5 units, so y equals shift left. Let's do the left first because that's with the x, so left would be x plus 2.5. And then the up 1 is plus 1 at the end. Notice that the plus 1 is not in the exponent. Number 4, write the equation for the function that results from each transformation applied to the base function. So if I want to reflect that function, that base, this base, in the x-axis, then I want to make the a value negative. So I'm going to do y equals, make it negative, keep the base to the exponent x. If I want to stretch it vertically by a factor of 3, that's also the a value. So I'm going to write y equals 3 times 1/3 to the x. Hope you have a fantastic day, and may the 4th be with you. Yeah, may the force be with you. Ha ha ha. Have a good day.